Last time we have seen the topic number 2, oscillator. We know that. What is a oscillator? Oscillator is a electronic circuit which convert DC energy into an AC energy at very high frequency. That can be convert DC energy into an AC energy. Also, we have seen the difference between amplifier and oscillator. In case of an amplifier, frequency and amplitude of a output signal that will be depends upon the frequency and amplitude of a input signal. And for amplifier, additional power is supplied by external DC source. Also, we know that in case of a oscillator, what is the oscillator? Oscillator is a circuit which converts DC energy into the AC energy. Oscillator is nothing but it is an amplifier in which positive feedback is fed from output to input. Positive feedback is fed from output to input. So in case of a oscillator, frequency and amplitude of the output, you know that in case of a amplifier, frequency and amplitude of a output that will be depends upon the input. But in case of a oscillator, frequency and amplitude of the output signal that will be depends upon the circuit itself. And oscillator does not require the external input. Without input, we have to get the oscillation. And its frequency of this oscillation and amplitude of that oscillation produced at the output that will be depends upon the circuit itself, and therefore the oscillator is the circuit that can be produce DC voltage into the AC voltage, and it keeps producing an output signal so long as DC power supply is connected. As if there is no DC power supply, then we have to get the output 0. Also, we have seen types of waveform: sine waveform, square waveform, triangular waveform, sawtooth waveform. This is the nature of the sine waveform. We know that sine waveform. We know that the square waveform with mathematical equation, mathematical function. What is the nature of the square waveform? We have to get the output at the square waveform. It is produced by using bistable multivibrator. It is produced by using flip-flop. Triangular waveform, the fundamental function for triangular waveform. In the same way, this sawtooth waveform, it is also called as a ramp voltage. It is also called as a time-based voltage, shift voltage. 3 types of a name it is given to this sawtooth waveform: ramp voltage, shift voltage, time-based voltage, sawtooth waveform. What is meant by ramp voltage, sawtooth voltage, or shift voltage, or time-based voltage? The voltage which linearly increases with time. This is the voltage which linearly increases with time is called as a shift voltage. जेव्हा टाइम वाढला, व्होल्टेज असं आपोआप वाढते, आहे का नाही? त्याला काय म्हणतो आपण? shift voltage म्हणतो. The voltage which linearly increases with time, such voltage is called as a shift voltage. Next, article 2.2, oscillation from tank circuit. This is the tank circuit. Tank circuit is nothing but the inductance parallel with the capacitance, and that can be produces the oscillation of a desired frequency, and it's a frequency that will be depends upon the value of the inductance and value of the capacitance. As we change the value of the inductance and capacitance, then frequency of the oscillation produced that will be changes. Therefore, here how oscillation that can be produced. Now, how this circuit that can be produces the oscillation. For this purpose, here we have to. This is the first circuit in which we can develop the charge on the capacitor by connecting this circuit to the power supply. That means connect this circuit to the power supply and develop the charge across this capacitor. That means electrostatic energy that can be developed across this capacitor. Now after that, switch is closed in figure 2. As switch is closed in figure 2, at the time what happened? This capacitor that can be discharged through this inductor. That means this electron on the lower plate that can be flowed in this direction towards this positive charge. As the electron flows in this direction, Therefore, what happens? As electron that can be flowed in this direction. Therefore, there is a flow of electron according to Boyle's law. When electron or current that can be flows through this conductor, then what happens? There is a magnetic flux, a magnetic field that can be developed surrounding to this conductor. And this magnetic flux, in this way, here there is a electrostatic energy that can be, when this capacitor, it is a completely discharged at that time, electrostatic energy that can be converted into the magnetic energy. And this here, here we have to say that in this way, once this magnetic field, magnetostatic field that can be collapsed, then again, as there is a change in the magnetic flux, at that time EMF is induced in this coil. Therefore, this capacitor, it is again charged with this polarity. That means on upper plate negative polarity and on lower plate there is a positive polarity, and therefore such a type of a charge accumulated by this capacitor, and here magnetostatic energy that can be converted into the electrostatic energy. Again, this electrostatic energy that can be converted into the magnetic energy. And this process is continued, and we have to conversion. That means we have to get the oscillation. That means charging of the capacitor and discharging of the capacitor. That means this cycle that can be produced, and here oscillation from the tank circuit that can be produced. That means this is the oscillation from the tank circuit. After that, here we have to see the damped oscillation. Damped oscillation, we know that in tank circuit we can use the capacitor, we can use the inductor. Inductor is nothing but a coil. It produced by this coil. It is built up by the wire, and we know that as the length of wire increases, then its resistance that can be increases. Also, therefore this resistance that can be opposite to this oscillation developed. That means in the tank circuit, there are resistors, there are coil, there are inductors, as well as there are capacitor. Capacitor have the dielectric losses, and inductor has the resistive and radiation losses. As current flows through this inductor, there is a magnetic flux that can be magnetic field that can be developed surrounding to this inductor, and therefore there are radiation losses and resistance losses in the inductor, as well as there are dielectric losses in the capacitor, and therefore here during each cycle of this oscillation, a small part of energy that can be used to remove these losses, to overcome these losses, and so that the amplitude of this oscillation that can be decreases continuously, and after certain time it becomes a zero, and therefore here we have to say that this tank circuit that can be produces a damped oscillation. That means decrease in amplitude oscillation. Why the tank circuit that can be produces the damped oscillation? Because there are a inductor have the resistance and resistive losses. Inductor have the radiation and resistive losses. Capacitor have the dielectric losses, and therefore some part of this energy of this each cycle that can be used to overcome these losses, and so that amplitude in each cycle that can be decreased here shown in figure. And due to this decrease in amplitude, after certain traveling this distance by this oscillation, this amplitude becomes a zero, and therefore this circuit, this tank circuit, that can be produced as a damped oscillation. Now we can draw the figure, damped oscillation figure in this way. Amplitude that can be decreases in each cycle. This amplitude denoted in this way. Here generally on y-axis there is a current or voltage, and generally on the x-axis there is a time. Why this amplitude that can be decreased? Why tank circuit that can be produced a damped oscillation? because the inductor have the radiation losses, resistive losses. Capacitor have the dielectric losses. In practical tank circuit, there are resistive and radiation losses in coil. Coil means inductor. Dielectric losses in capacitor. And during each cycle, a small part of the energy is used to overcome these losses. And so the amplitude of the oscillation decreases continuously. So the amplitude of the oscillating current decreases and eventually it becomes a zero. And therefore the tank circuit that can be produces the damped oscillation. What is the frequency of a oscillation produced by this tank circuit? The frequency of a oscillation is nothing but the resonant frequency of the tank circuit. Frequency of the oscillation is nothing but the resonant frequency of a tank circuit. And it is given by the equation F is equal to 1 divided by twice pi under root of a LC. We have determined the resonant frequency of the LCR series circuit in BSc part first. One that the resonant frequency of the LCR series circuit, it is given by the equation F is equal to 1 divided by twice pi under root of LC. Now here there is a tank circuit, but this inductance and capacitor which are in series. That's why while calculating the frequency, then we have to get the, it is no doubt it is a parallel inductance and capacitor. But these are connected in series in this way. And therefore the frequency of a oscillation produced by the tank circuit is nothing but the value of its, what is the value of its inductance, what is the value of a capacitance. As the inductance increases, capacitor increases, it's a frequency that can be increases or decreases. Frequency that can be decreases. Now this is the resonant frequency of the tank circuit. The frequency of a oscillation is nothing but the resonant frequency of a tank circuit, and resonant frequency of a tank circuit is given by the equation F is equal to 1 divided by twice pi under root of a LC. This is the frequency. Now after that here we have to say that now here undamped oscillation, next article, undamped oscillation. Undamped oscillation from tank circuit. Only that this is the damped oscillation. Now here we have to produce the undamped oscillation. That means there is a no loss of energy. That means there is no loss of energy. Energy that can be lost by the inductor as well as by the capacitor, because they have dielectric losses in case of a capacitor, radiation and resistance losses in case of a inductor. Therefore, how we can produce the undamped oscillation? That means its amplitude remains a constant, undamped. There is no damping of amplitude. That means there is no decreasing of amplitude. Therefore, here we have to say that the tank circuit produces a damped oscillation. One that the tank circuit that can be produces the damped oscillation, and these damped oscillation are not useful for radio transformation. To measure, we know that in your home there is a radio receiver, and we can singing the sound or entertainment by using this radio receiver. At that time, we have to get the signal from radio broadcasting. It is a radio signal, and if radio broadcasting center it is a large distance, then how we can receive the radio signal from this radio broadcasting to that TV receiver? That means there is a losses, and therefore due to this losses, what happened? Due to its limited range, we have to get the excessive distortion for good radio transformation. And therefore here we have to say that these damped oscillations are not useful for radio transformation because of their limited range and excessive distortion for good transmission. Because of their limited range and excessive distortion for good radio transformation. And here we know that we need undamped oscillation, which can be produced of same additional energy is supplied in correct phase and correct direction. Now, well, here we have to see the undamped oscillation from tank circuit. या ठिकाणी जरा थोडं रेंजचा प्रॉब्लेम येतोय. Undamped oscillation from tank circuit. Wouldn't that the tank circuit produces a damped oscillation? Here our aim is to produce undamped oscillation. And why this we does not use damped oscillation? These damped oscillation are not useful for radio transformation. रेडिओ सिग्नल जर ट्रान्सफॉर्म करायचे असेल किंवा रेडिओ जर ट्रान्सफॉर्म करायचे असतील तर ते डॅम्प्ड ऑसिलेशन आपण यूज करू शकत नाही बिकॉज ऑफ देअर लिमिटेड रेंज their limited range and excessive distortion for good radio transformation. Excessive distortion for good radio transformation. Now we know that here we need undamped oscillation and it can be produced by adding, it can be produced of some additional energy, it is not same, but it is some additional energy supplied to correct phase and correct direction to the LC circuit. Some additional energy that can be here what here we can add the some energy in correct phase and correct direction to the LC circuit to make up I square R losses occurring in the circuit. And therefore here we have to get this for undamped oscillation. That means here we have to get this damped oscillation. This is about undamped oscillation. Therefore, what is undamped oscillation from tank circuit? We know that the tank circuit produces a damped oscillation. And this damped oscillation, it is not useful for radio transformation because of their limited range and excessive distortion for good radio transformation. There is a distortion in damped oscillation. Its range is limited. And so that this damped oscillation, it is not useful. Also, how we can produce the undamped oscillation? And we know that we need undamped oscillation which can be produced by adding some energy in correct phase and correct direction in the LC circuit so that this I square R does not, this loss does not occur in the circuit. And we have to get this oscillation. This is the undamped oscillation. That means its amplitude does not decrease, but its amplitude remains a constant. This amplitude is a constant, this amplitude is a constant, this amplitude is a constant. Therefore, this what is mean by oscillation from tank circuit, which is undamped oscillation? That means this is the undamped oscillation. How we can produce? By adding certain energy, some energy in the LC circuit with some phase, with correct phase and correct direction. इथे amplitude कमी झालं ना तेवढंच energy, जेवढं कमी झालं तेवढंच ते ऍड करायचं आणि किती कशी डायरेक्शन आहे त्या पद्धतीनेच ते ऍड करायचं. फेज कसा आहे त्या पद्धतीनेच ऍड करायची. डायरेक्शन कशी आहे तेवढंच त्या पद्धतीने ते तेवढी एनर्जी इथं डिक्रीज झालं तेवढंच ऍड करायचं. आणि त्यामुळे ह्या ठिकाणी प्रत्येक सायकलचा amplitude कसा राहील सारखा राहील आणि आपल्याला या ठिकाणी undamped oscillation मिळतील. Now after that here we have to see the Barkhausen criteria for sustained oscillation. This question is asked for state Barkhausen criteria for sustained oscillation. Therefore, what is the condition for sustained oscillation? काय condition आहे for sustained oscillation? This is called as a Barkhausen condition. That means the Barkhausen criteria for sustained oscillation is nothing but the in what condition we have to get the oscillation, sustained oscillation. It is given by the scientist Barkhosein, and that's why it is called as a Barkhosein criteria for sustained oscillation. Therefore, what is the we know that gain with feedback is given by the equation. This gives the condition under which the feedback amplifier can be work as an oscillator. Barkhosein criteria म्हणजे condition. This gives the condition under which a feedback amplifier can be work as a oscillator. Oscillator कधी act होते? त्यासाठी here we have to consider the voltage gain of amplifier with feedback. Voltage gain of the amplifier with feedback is given by the equation. AVF is equal to AV divided by 1 minus KV. Last time we have determined the voltage gain of a amplifier with feedback. It is also called as a closed loop gain. Gain with feedback. Closed loop gain. It is given by the equation AV divided by 1 minus KV. AV represents the gain of the amplifier without feedback. This AV represents gain of the amplifier without feedback. This K represents feedback factor. The value of feedback factor is less than 1 in case of a passive component. The value of K is greater than 1 in case of an active component. K ची value कशी राहते? Greater than 1. And the product K into AV, this product is called as a loop gain. The product K into AV is called as a loop gain. Therefore, what is the Barkhosein condition? काय Barkhosein condition? That means AV, K into AV, that is equal to 1. K into AV, that is equal to 1. And this is called as a Barkhosein criteria for sustained oscillation. त्यालाच काय म्हणतो आपण Barkhosein criteria for sustained oscillation. When K into AV that is equal to 1, then what happened? This equation. The voltage gain of an amplifier with feedback हे equation काय मिळते आपल्याला? AVF is equal to AV divided by 1 minus KV. KV जर 1 ठेवलं तर AV divided by 1 minus 1 आपल्याला काय मिळेल? AV divided by 0 आणि AV divided by 0 कुठल्याही क्वांटिटीला 0 ने डिवाइड केलं काय मिळेल आपल्याला? इन्फिनिटी मिळेल. As AV divided by 0, then AVF that means becomes equal to infinity. AVF काय मिळेल आपल्याला? इन्फिनिटी मिळेल. आणि AVF जर इन्फिनिटी मिळालं तर V0 dash divided by VI. AVF is equal to काय? V0 dash divided by VI. VI 0 असेल तरच V0 dash आपल्याला किती मिळतंय? VI 0 असेल तर AVF किती मिळतंय? इन्फिनिटी. म्हणजे in case of a oscillator there is no input signal, but in case of a amplifier there is a certain input signal. Amplifier च्या बाबतीत इनपुट सिग्नल लागतात, मात्र ऑसिलेटरच्या बाबतीत इनपुट सिग्नलची गरज नाही. विदाउट इनपुट वी हॅव टू गेट द ऑसिलेशन. PI that is equal to 0, that means that without input we have to get the oscillation. Therefore, what is the condition for Barkhosein criteria? Barkhosein criteria. Barkhosein condition काय? Mod of a K into AV that is equal to 1. That means loop gain must equal to 1. This is the Barkhosein criteria for sustained oscillation. किती सोपं आहे सांगा. म्हणजे the condition that can be gives us this condition under which feedback amplifier can be act as a oscillator. मग त्यासाठी काय करणार? व्होल्टेज गेनचं इक्वेशन माहित आहे विथ फीडबॅकचं. द व्होल्टेज गेन ऑफ एम्प्लिफायर विथ फीडबॅक तुम्हाला झालेलं आहे जनरल थिअरी ऑफ फीडबॅक मध्ये. AVF that is equal to 1 divided by AVF that is equal to AV divided by 1 minus KV. किंवा AVF that is equal to V0 dash divided by VI. आणि जर तुमचं AV माहित आहे काय आहे AV? गेन विदाउट फीडबॅक. K माहित आहे फीडबॅक फॅक्टर. के इंटू एव्ही माहित आहे काय लूप गेन, आणि लूप गेन जर 1 असेल तर ईव्हीएफ किती मिळतो? इन्फिनिटी मिळतो. आणि ईव्हीएफ जर इन्फिनिटी मिळत असेल त्यासाठी व्ही हाय किती असायला पाहिजे? व्ही हाय किती असायला पाहिजे? 0 असायला पाहिजे. म्हणजे इनपुट 0 असताना तरी सुद्धा आपल्याला आउटपुट मिळते. इनपुट 0 असताना तरी सुद्धा आपल्याला ऑसिलेशन मिळतात. आणि दिस इज द कंडिशन फॉर बार्कोसेन क्रायटेरिया. आणि यालाच काय म्हणतो आपण? कंडिशन फॉर बार्कोसेन क्रायटेरिया. मग व्हॉट इज द कंडिशन फॉर बार्कोसेन क्रायटेरिया? Loop gain must equal to 0. Mod of k into AV that is equal to 1. This is the condition for Barkhausen criteria. दुसरं लेक्चर बी आहे, लिंक दुसरी वापरायची लगेच. मग व्हॉट इज द Barkhausen criteria for sustained oscillation? We have seen damped oscillation. Damped oscillation. Damped oscillation काय आहे? This is the damped oscillation. Damped oscillation. After that, undamped oscillation. After that, Barkhausen criteria. Barkhausen criteria mathematically objective मध्ये विचारलं जातं. The Barkhausen criteria for sustained oscillation is k into AV that is equal to 0, k into AV that is equal to 1, k into AV that is equal to plus 1, किंवा greater than 1. Therefore, here we have to greater than equal to 0. That means k into AV that is equal to 1. This is the Barkhausen criteria. पुस्तकामध्ये खाली लिहिलेलं असेल काहीतरी. हा सर एकदा that is equal to 1. This is the most important. This is the condition for Barkhausen criteria. Now after that, here we have to see the concept of a AF and RF oscillator. Now what is the oscillator? Oscillator is the circuit which convert DC power into an AC power. Oscillator is the circuit which convert DC power into DC power into the AC power. Oscillator is the circuit which convert DC power into the AC power. DC power that can be converted into the AC power, this is called as a oscillator. DC power जर कन्वर्ट झाली तर त्यालाच काय म्हणतो आपण? ऑसिलेटर म्हणतो. Now here we have to say that an oscillator converts DC power, unidirectional power, into AC power. And the frequency of this oscillation produced that will be depends upon the system itself. You know that we have to get the output in case of a oscillation, and its amplitude, its frequency that will be depends upon the circuit itself. That means here we have to get the oscillation. Oscillator that can be produces the oscillation that will be depends upon the constants of the system. कॉन्स्टंट म्हणजे सर्किट इटसेल्फ, इंडक्टन्स कितीचा यूज केलेला आहे, रेजिस्टन्स कितीचा यूज केलेला आहे, कॅपॅसिटर कितीचा यूज केलेला आहे, त्याच्यावर त्याची फ्रिक्वेन्सी डिपेंड असेल. The oscillations are also classified into the 4 types according to their frequency. We can change the frequency by changing the component in the circuit, by constant in the circuit, by component in the circuit, not constant. कॉन्स्टंट सर्किटच्या बाबतीत काय राहतात? कॉन्स्टंट आहेत, गेन आहे, इतर बऱ्याचशा गोष्टी कॉन्स्टंट असू शकतात, पण we can change the components. Now there are 4 types of oscillator: radio frequency oscillator, radio frequency oscillator, very high frequency oscillator, ultra high frequency oscillator. And now we know that what is meant by audio frequency oscillator. The circuit that can be produces the oscillation whose frequency lies in between 20 Hz to 20 kHz. Such oscillation that can be produced by using oscillator is called as a audio frequency oscillator. You know that the audio frequency range, it is lies in the range 20 Hz to 20 kHz. And audio frequency oscillator are oscillator which generates the waves of frequency 20 Hz to 20 kilohertz. The best example of a audio frequency oscillator, that is a RC coupled phase shift oscillator. RC phase shift oscillator. Now here we have to say that the phase shift oscillator, it is the best example. We have to see the first article of this oscillator. We have to study the different 4 types of oscillator: phase shift oscillator, Colpitts oscillator, Hartley oscillator, crystal oscillator. Now in first article, that is a phase shift oscillator. Now therefore audio frequency oscillator that can be produces the oscillation whose frequency lies in the range 20 Hz to 20 kilohertz. Now radio frequency किती असेल मग? Audio frequency 20 Hz to 20 kilohertz आहे. Radio frequency range it is in the range 20 kilohertz to 30 kilohertz. 20 kilohertz to up to the 100 kilohertz. So radio frequency range जे आहे ते 20 kilohertz to 30 kilohertz. Colpitts oscillator, Hartley oscillator, these are the best example of this radio frequency oscillator. Very high frequency oscillator, above the 30 kilohertz, above the 1 mega hertz. Here 20 kilohertz to 300 kilohertz. This is the frequency of a radio frequency oscillator. And above the 300 kilohertz, this oscillator is very high frequency oscillator. Now crystal oscillator, it is the best example of a very high frequency oscillator, above the 1 mega hertz. Therefore here we have to say that concept of a oscillator. Concept of a audio frequency oscillator, radio frequency oscillator. Audio frequency oscillator कशाला म्हणायचं? The oscillator which generates a audio frequency signal. Its a frequency range, it is in the between the 20 Hz to 20 kilohertz. त्याला काय म्हणतो आपण? ऑडिओ फ्रिक्वेन्सी ऑसिलेटर. म्हणजे ऑडिओ फ्रिक्वेन्सी ऑसिलेटर कुठले झाले तुमच्या लक्षात आलं? जे ऑसिलेटर दॅट कॅन बी प्रोड्युसेस द फ्रिक्वेन्सी रेंज, इट इज इन द रेंज 20 Hz to 20 kilohertz, त्याला काय म्हणतो आपण? ऑडिओ ऑसिलेटर. आणि रेडिओ फ्रिक्वेन्सी अबाव 20 किलोहर्ट्ज फ्रिक्वेन्सी ज्या ऑसिलेटरची असते, म्हणजे ज्या ऑसिलेशनची असेल, ऑसिलेटर काय ऑसिलेशन, त्यालाच काय म्हणतो आपण? रेडिओ फ्रिक्वेन्सी ऑसिलेटर. आणि अबाव 1 मेगाहर्ट्ज असेल तर ती व्हेरी हाय फ्रिक्वेन्सी ऑसिलेटर, अल्ट्रा हाय फ्रिक्वेन्सी ऑसिलेटर, त्या हाय फ्रिक्वेन्सीच्या बाबतीत वापरतो आपण. नाउ नेक्स्ट आर्टिकल कुठली? डॅम्प्ड ऑसिलेशन.